Now let's talk about magnification. So in simple terms, magnification is defined as how the image is being formed. Is it magnified, padakon, or is it pagamyon, which is demagnified? So you can also see if the image is formed upright or is it formed inverted, nakabali. So magnification is being represented by the symbol M, which is just equal to the height of the image over the height of the object. Now, in also relationship with its distance, we can also derive its formula, which is equal to negative distance of the image over the distance of the object. Now, if the magnification is negative, the image will be inverted. Now, if our magnification is positive, then the image will be upright. So, in our past example, we have a concave mirror and then our optic axis just like that, and then we have our center right here. Our image is formed directly above the center. We noticed that the image is being formed, the object is being formed right above the center, and the image will be formed right beneath the center. So if you can notice that this is the object and this is our image. So the distance between the mirror and the object is represented by DO. The distance between the mirror and the image is being represented as DI. So in our formula, we have M. Remember, all figures, all symbols, images, numbers that are on the left side of the mirror is always positive. If naadiri sa right side, they are all negative. So we have our DI, which is positive DI over DO. Our M is negative, which is inverted, like here, inverted auto image. Now, if we have our image located on the right side, we don't know if naadiri sa taas o naadiri sa ubos. Basta, if our image is on the right side, we have a negative DI. Diba? So, according to our formula, if we have a negative DI over a positive DO, distance of the object, our M will be what? Our M will be, cancel ang negative, because negative times negative is positive, so our M will be a positive. Now, if our M is positive, then how will be the image formed? It will be upright. So it will be here. We don't know if naadiri, basta the image is upright. So now, let's proceed. Ayun na, no? Let's proceed to another topic. So now we always discuss concave mirrors. Now let us discuss what are convex mirrors. So we know a concave mirror is if the light rays are coming in this direction, pasulod sa iyang cave. Sa convex mirror, gikan sa gawas, sa cave, ang rays mo passes through sa iya. That is a convex mirror. Sa ato na siyang control. So let us place a convex mirror right here. And let us remember, let us not forget our optical axis, which is just that passes through the center of the mirror, which is something like this. Now, if we can remember, if ato ning kompletohon ang iyang mirror, the figure that will be formed is a circle, diba? Diba ito ning kompletohon, makita nato nga mura siya circle. Now, a circle always have a center, which is example just right here. Let us label it as the center. Now, there's also another important part, which is our focal point. So the focal point is just the radius over 2. So which is just, if our radius is right here, distance from the mirror to the center, then our focal point is tunga ra ani. So in other words, it is just tunga sa center to the mirror, which is something just like here. Let's label it with letter F. This is our focal point. So now, our light rays will come at the side. Let us put our object right here. Our object right here. So, we know that if a light is being projected sa isa ka image, then all rays will come forth in different directions. So now, in our past discussion, we have 3 rules in image forming sa concave mirrors. Now, ato gihapon gamiton katong tulo ka rules in our image formation sa atong convex mirrors. So what are those 3 rules again? Diba? Image formation in convex mode. So the first rule is all straight rays that passes through the mirror will pass through our focal point. So straight rays, this is a mathematical symbol of ray. Isa ka point, remember a line. A line extends in both directions, left and right. Now, ang ray, isa ka point, nagpundong, and only isa ka direction ang mag-extends infinitely. So, straight rays will pass through the focal point. Will pass through our focal point, which is F. Now, asa man na nato i-drawing? So, coming from the tip of our object, for example, kanya ang atong na-illuminated sa light source. A straight ray, imagine that is a straight ray that passes through the mirror. Now, if the ray will pass through the mirror, unsa na siyang klaseng ray? It will become a virtual ray. This is all a real rays. If they passes through a convex mirror, they become virtual rays. So it will be represented as a dashed line. So in this case, I'm using a blue pentel pen. So they will pass through the focal point. Right there. So if we notice, this ray will extend from here to there. If straight na siya. So we label it as ray number 1. Now, our rule number 2, we have rays that passes through F will be parallel. So, kung saan man na pag-drawing, saan man na pag-illustrate na to. So, ganito ang ray, there is one ray that will pass through our focal point here, and it will come out parallel sa isa ka atong optic axis. So, how do we draw that? There is a ray that pass through our focal point. So, if mulagpas na sa mirror, it will become a virtual ray. It will pass through the mirror. So, asa man nga dapit na maparallel siya. So, diri na siya dapit. It will pass through the mirror, pass through the focal point. However, its reflection will be parallel. Gets? It will be parallel. Now, if ato ng sumpayon, it will go here. Right? So, in our concave mirrors, if example, dirigita ng light, there is a ray na mo diretsyo siya diri mo banda mo kuan siya diri atong focal point, then it will come out parallel. Diba yung ato po sa concave mirror na to. Now, we will label this as the ray number 2. So, for our third rule, they are just very simple. Rays that passes through the center will never bend. So, asa man na? There is a ray that passes through the center and it will never bend. Diretso na siya. So, that is, if we draw, if we illustrate, it will become just like here. The ray, and it will pass through our center. It's like that. So, we label it as ray number 3. So, di ba sa atong discussion, kung asa tanang rays mag-meet, whether real ray or virtual ray, dito ang atong image ma-form. So, asa ni diri nga illustration, mag-meet ang tanang rays, whether virtual or real. If you can see, it will meet the stripe here. Diri nga point. So, our image will be formed diha nga part. Diba? That is the image formation in convex mirror. Now, to conclude, we have our image. Unsa man siya? Is it a virtual image or is it a real image? So sa atong pagkahibalo, they are all virtual rays. Now, unsay ma-form nga image? Of course, the image is also virtual. Now, another one is the image demagnified or magnified. Nidako ba ang atong image from here to here? Nidako ba siya or nigamay? Diba? Nigamay? So, the image is virtual and demagnified. Now, another is the image upright or nakabalik. So, if you can notice, pareho lang sila illustration ng camera. So, the image is also upright. So, to conclude, the image that is formed in convex mirrors are or is a virtual image. It is demagnified and it is upright. That's very easy. Thank you. Now in this video, we're going to talk about the refraction of light. Now refraction is a property of light that causes it to bend when it passes through one medium to another medium. So for example, we have an illustration like this. We have a glass half full of water, and then when we put an object right to it, we notice that it somehow bends, di ba? So that is what refraction is. So let us illustrate here in our diagram. So we have our interface. Kaning dili murag maghimo og FBD diagram. So this is our normal line, which is perpendicular to our surface interface. So now, this is taas, we have our air. Diri sa ubos, we have our water. Air, water. So now, when we have our object or a light that passes through our point of incidence, there are three things that can happen. First one is it can reflect. The light will be reflected. And another one, it can be refracted. And the third one, which I'm not going to discuss in this video, is that light will be absorbed by the object, in which wala kay makita ang reflection or refraction. So now, this ray right here, we call it as our incident ray. So, the angle between our incident ray and our normal line is represented as theta I, or the angle of incidence. Now, here, we call this as our reflected ray. So, the angle between here and our reflected ray is called the theta R, or theta reflected. Now, this one we call this as our refracted ray. So, the angle between refracted ray and our normal line is called our theta refracted, or theta RA. So now, if we know in our discussion in our law of reflection that theta I is just the same as theta reflected. So, if we have a 45-degree angle for our theta of incidence, or angle of incidence, then our angle of reflection is just equal to also 45 degrees. Now, in this topic, we're going to discuss how to find the angle of refraction, which is also theta RA. Now, to find this, we're going to use something called Snell's law. Snell's law. So here, it just says that N1 sine theta 1 is just equal to N2 sine theta 2. So we're going to discuss what is N1. So N1 is just the index of our refraction. So it is a constant. So it will be given to you. So kung unsa ni, the N1 or the index of refraction is just the ratio of the speed of light to the ratio. It is just the ratio of the speed of light to the speed of light in the certain medium. If atong tan-awon, it is equal to 1.003. So in this case, we're just going to use 1. Okay. Now this is not exactly 1, but it is just an approximation. So the speed of light in a vacuum, or the index of refraction in a vacuum, is always equal to exactly 1. So mao to sa vacuum. However, sa air, approximately 1. So in H2O, in water, the index of refraction is just equal to 1.33. So now, we're going to find what is our theta 2, or our index of refraction. Theta 1 is just equal to our theta of incidence. So, to find theta 2, we just divide it by our N2 sine N2 sine. So sa Pica's pod, we divide sine. So we can cancel out. Theta 2 is just equal to N1 sine theta 1 over N2. So if you can notice, this is a product. So we can multiply it by 1 over sine. 1 over sine is just equal to the inverse sine. Inverse sine of N1 sine theta 1 over N2. So that is our formula in finding our theta of refraction. So we can now plug in our values in our formula. So we can have theta 2, or the angle of refraction, is just equal to the inverse sine of N1, which is exactly at approximately 1 times sine 45. Our theta 1, which is our theta of incidence, or angle of incidence, which is just 45. Now over N2, which is 1.33. So if we put it into our calculator, the answer will be approximately 12 degrees. So our angle of refraction is equal to 32.12 degrees. Okay na? So now, what about if we're going from higher index of refraction to lower index of refraction? So if makita natin from 1 to 1.33, this is from low to high. Now what about if it is from high to low? So akong tanggalan ha. Na. So we're going to use the illustration between glass and air. What if light passes through the glass and through the air? So we have a light coming to our point of incidence, just right here, and we know that it can refract. Oh no. It can refract, or it can reflect. Now, if we have before I forget, that the index of refraction for glass is just exactly 1.5. For air, we have 1. So, if we have an angle here of 45 degrees for our theta of incidence, our reflected will just equal to 45 degrees also. So let's look upon and let's solve the reflected angle, theta RA. In our formula, we get inverse sine of N1, which is our N1, which is our theta of incidence, and N is equal to 1.5 times sine 45 over our N1, which is N2, which is our N2, equal to 1. After you calculate, we have now let's talk about getting the angle of refraction going from higher index of refraction 1.5 from glass to the air, which is 1. So we're going to use the illustration of what if a light passes through the glass. For example, right here. What if a light passes through here, then what would be the angle of refraction would be? So we get our, before I forget, the angle of refraction for the glass is approximately 1.5 and for the air this is just 1. So to get our angle of refraction, if if it is 40 degrees, our angle of incidence is 40 degrees, what would be the angle of refraction? Now, our angle of refraction, our theta 2, this is our theta 1, incidence, angle of incidence. This is our N1. This is our N2, and this is our theta 2. Okay? So our theta 2 is just equal to inverse sine of N sub 1, which is just 1.5 sine our theta of incidence, which is 40 degrees. Our angle of incidence is 40 degrees. And then divided by N2, which is 1. So, if we calculate this, what would we get? We will get approximately 74.62 degrees. So, our theta theta RA, which is angle of refraction, is just equal to, this is equal to 74.62 degrees. So it is something like, something right here, 74.62 degrees. So, if atong mapansin, so now, if you notice, if a ray is being projected to our point of incidence higher than here, then our refracted ray will go lower. The angle would be going to 190 degrees. So, then however, if you put another ray right here, then the ray would be reflected. Now this is what we call total internal reflection. So if we have a ray that passes through our point of incidence and it would never be refracted, tanang ray kay ma-reflect. Acceptan? So before that, we call that as total internal refraction. So now, before we have our total of internal reflection, which means, di ba, that all rays will never be refracted na. They will all be reflected. So before we have our total internal refraction, we have what we call a critical angle. There's a critical angle, which is theta C. So this theta C is that when a ray is being projected to our point of incidence, then the ray that is coming out is equal to 90 degrees. Is equal to 90 degrees. Ha? That is our critical angle, ha? It is equal to a right angle, 90 degrees. So, kung saan man napagkuha ang atong critical angle. So, balik na punta sa atong formula, which is equal to N1 sine theta 1 is equal to N2 sine theta 2. So our theta 1 is equal to our critical angle. Our theta 2 is equal to 90 degrees. So we have N1 sine critical angle is equal to N2 sine 90 degrees. So how are we going to get the theta C or the angle, critical angle? Then we just divide N1 sine. Beautiful, because N1 sine. So we have our theta C is equal to N2 sine 90 over N1 times 1 over sine. So if you're going to complete the formula, we have inverse sine of N2 sine 90 and 1. That is how we get our critical angle. So if you plug in our values, we have inverse sine of N2, which is equal to 1 sine 90 over N1, which is approximately 1.5. So what angle would we get? We have an angle of 40.81 degrees. So our theta C or our critical angle is just equal to 40.81 degrees. So if we can notice, all angle, tanan ng angle that is higher than our theta C, higher than 40.81, 45, 60, 70, all rays will be reflected na. Dili na siya mo refract. Tanan, for example, if this is our critical angle. Tanan nga angle na adiri, they will all reflect. Diri sila padung. Now, if the angle is 30, 20, 10, this is less than our critical angle, then the rays will be refracted. In this case, di ba gaina, this is 40 degrees, then it was reflected 74.62 degrees from our normal line. That is how you get the critical angle. So that is all in our topic of refraction. Thank you. Now let's talk about lenses. Now that we know the Snell's law, the index of refraction, and the total internal refraction, let's apply it on our lenses. Now, imagine we have a curved mirror. Now, it is curved on both sides. Now, there is a ray that passes through the center of this lens. And the ray will pass through without ends. Now, if I took a ray and it will hit the top near of our lens, then it will bend a little bit. Now, this ray, magpadayon na ni diri na. However, maigo man ni siya sa diri isa ka ray, then it will bend na pod, mo bend na po siya kalit ana. That will continue on. Duha ang iyang maigo side sa lenses diri and diri mo bend siya gamay diri pag abot na po diri sa pikas mo bend na po siya. That will be the same on our bottom ray. If maigo kani nga lens, it will bend a little bit, mo bend na po siya kalit. Now, lenses obey the total internal refraction rule. So if we have all straight rays, they will all pass through here. And this here is our focus or our focal point. So we have very different kinds of lenses. We have a lens that is curve on both sides, curve pana. We call this as biconvex lenses. Now, if we have a lens that is curved pagawas on both sides, we call it as biconcave. Now, how about if we have a lens that is curved on one side and it is closed on the other? This is a plano convex lens. If sa pikas na po siya mo curve, and then kuha na po sa pikas, ana, this is called a plano concave lens. Now let's talk about the image formation in our thin lens. So we have our lens here. So in our thin lens, our center is at the center of our lens. So we have our optic axis right here. So ang atong center na diri diba sa atong concave mirror and convex mirror nakasagawa sa ang center. So here in our lenses, our center is right at the center sa lens. So if nadiri ang center, where is our focus? So our focus is located on both sides of the lens. If this is our center, if we take here, this is our focus. Another one here. Focus, do atong focus. So they are symmetrical to each other, which means pareha sila sukat. Pareha sila og focal length. Kung sa ang diri more putang diri So now let's put our object right here. So now balik ta sa atong 3 rules in image formation. So first rule is parallel rays passes through our focus. Now, we take a straight ray that is parallel to an optic axis, and it will bend here, and pag-abot na po diri bend siya, and it will pass through our focus. It will pass through our focus. Now, this is our ray number 1. Number 2, rays that passes through our focus will be parallel. Asa man siya nga focus. Remember, ang namugawas diri are all real rays na siya. So, rule number 2, rays that passes through our focus, which is right here. Rays that passes through our focus, open the kalit, will become parallel. That is, wait. That is our ray number 2. So makikita na tagkuan, intersection. Actually, yan na ito kinanglan kuan. Kaning third rule. However, for the sake of this lesson, let us continue. Ray number 3 Rays that passes through the center, not bend. Coming down, rays that passes through our center, do not bend. So now, asa man ma-form ang atong intersection. Now, they all passes through here. So, asa man natong kuan, atong image ma-form. The base of our image will be right here. And the tip of our object, or the image, will be right here. So, kana. That is how the image formation in our thin lens. So, to conclude, we have the image formation in thin lens is the image is real. Second, it is demagnified. And lastly, it is inverted. So that is the image formation in thin lens. It will be real, the image will be real, demagnified, and also inverted.